Hello everyone. Today we're going over 6.4 equations with rational expressions. The graphs section will be a separate video. So solving rational equations. So we've already talked about rational expressions. That's a polynomial divided by a polynomial. Now we're going to be discussing how we would solve that for the variable if there's an equal sign. So it's a three-step process, and the first step is determine the domain of the variable. This is because sometimes we're going to get some answers that don't make sense or make the equation go to an undefined answer. So this is just to exclude, we'll just say bad answers. And I'll put an arrow that says make equation undefined. Okay, in parentheses I will write divide by 0. So like x divided by 0. Something divided by 0 makes it undefined, okay? So that's our first step, okay? That's really not a step in terms of solving. It's just kind of a check at the end to make sure our answer makes sense, okay? After this, we move on to step 2. That's multiply each side of the equation by the least common multiple, okay, the LCM. So this is to get rid of denominators. Our equations become much more simple when we don't have fractions. So the whole goal is to get rid of these fractions so that we don't have any issues. And then the last step is solve. Once we have no fractions, it just becomes a multi-step equation, which we should be pretty good at by now, okay? So let's look at example 1. Once we put this into practice, it becomes a little bit more clear, okay? So the first thing we're going to do is we need step 1 to determine the domain. So we're going to look at the denominators of each one of these fractions, okay? Now, we've already discussed how to do this, but we're going to say this cannot equal 0, okay? So this function's domain will be all real numbers except for things that make the denominators in each fraction go to 0. So what we're going to do is we're going to say this whole denominator here, x, and we're going to say this cannot equal 0, and then we're going to solve for x. Well, there's nothing to solve. We already know that x cannot equal 0, so that's one of our exclusions, okay? X cannot equal 0. Let's look at the second denominator. Here we have 2. What will make this denominator go to 0? And the answer is nothing. There's no value of x, so there's nothing to input, there's nothing to change, it's just 2. So this one's good. There's nothing, this is still part of the domain of all real numbers. Okay, and then we have the third fraction, and we're going to see it's the same case. So we need to say 2x cannot be equal to 0. We want to see what will make this denominator go to 0, because that will make it undefined. 7 divided by 0 is undefined, and we don't want that. So we're going to solve for x here. We divide both sides by 2, and we get x cannot be equal to 0. 0 divided by 2 is 0. So we see that x just can't equal 0. Everything else is good, okay? So everything else fits within the domain, okay? So what I'm going to do is, if you want to pause and write this down, that's great. I am going to shrink this down so I have a little bit more room to work, okay? Because we need some room in order to multiply by the least common multiple. Okay, I'm having troubles here. There. Okay, so now I need to determine what will make all of my denominators cancel out. Okay, so I need to think of what are the factors of the denominator, and we have x, we have 2, and we have 2x. Those are all factors. What number has x, 2, and 2x as factors? Okay, that's the question. That's the least common multiple, okay? We could say x, but that'd be wrong because 2 is not a factor of x, so that's bad, okay? We could say 2, whoops, I was using green, 2, but that's not good because x is not a factor of 2, so that's bad. Now let's try 2x. Is x a factor of 2x? Yes. Check. Is 2 a factor of 2x? Yes. Check. Is 2x a factor of 2x? Yes. Check. So we have all three conditions. We are going to multiply both sides by 2x. Here's what happens. When we multiply by 2x, we're going to multiply each term by 2x. Okay, so here we have 2 over x minus 3 over 2, and I'm going to show the multiplication in just a second. Okay, in a separate video, I will go over the other examples, but just one example for this video. So I multiply by 2x to each one of these terms. Now, if you want, you can put 2x over 1 if that makes you feel a little bit more comfortable multiplying the fractions. Okay, now we could multiply all the fractions out and then cancel and simplify later. I like to cancel before I multiply. So let's take a look and see what happens when we cancel. Okay, I'm going to use purple actually. All right, so look at the first fraction. What could we cancel there? The only thing we can cancel, what's in the top and also in the bottom, is x. So we're going to cancel the x's, and what are we left with? We're left with 2 times 2 minus. We're going to keep the minus the same. Next fraction, we have 3 over 2 times 2 over x. The only thing in the top and bottom is 2, so we're going to cancel the 2's. What's left? The 3 times the x. You see why 2x was a good choice for us, because it canceled the x and the 2. Let's see what happens with the third one. So we have 7 over 2x times 2x over 1. The only thing that's in the top and bottom is a 2x and a 2x. Okay, or if you wanted, you could just cancel the 2 with the 2 and the x with the x. It's the same thing. What's left? Well, we have 1 on the top, 1 on the bottom. We have 7 times 1, which is 7 over 1, which is just 7. Now do you see how we have a much simpler equation to work with? Okay, this is much easier than the original monstrosity that we were dealing with. Okay, now we're just going to simplify. So we have 4 minus 3x equals 7. I'm going to subtract 4 from both sides, minus 4. Okay, and I get negative 3x equals 3. I divide by negative 3 to get x by itself. I get x equals negative 1. Now, before you say this is my answer, we have to check it with our domain. Does our domain exclude this answer we just found? And the answer is no. Negative 1 is not equal to 0. Okay, it's part of the all reals domain. Okay, the only thing that we can't accept is 0. So this is our solution. Okay, this checks out. Now we're going to see in the next video that there's cases where we have to exclude the answer that we find. See you next time.